My voice is audible. Please type the message in the chat box. Okay, so my voice is clear. So just give me the 5 minutes. Just we started in the 5 minutes. Hello, sir. We are waiting for 2, 3 few clients. So for that reason, we are started in the next 5 minutes. Okay, good afternoon, everyone. It's me, Abhishek from the MIDAS IT. So today we are conducting the next session for the analysis of a multi-storage structure and the verification using the MIDAS Gen software. It's a part two. The previously we saw the how to model the entire structure by using the MIDAS Gen. So now the next part is how to the design and the how to get the results from the by using the MIDAS Gen. So before I started, I just review about the previous cases, how we model the entire thing. So previously we did the DXF file and we imported from the DXF to the MIDAS and then we started for the next station. Once we import into the model, we are going for the properties. We first make the material property and then we go to the next section property. Once we did the section property, then first we assign all the property to the tentatively or we can say the individual elements by just dragging from the tree menu. Okay, so by dragging from the tree menu, you already assign the entire thing. The now next step is draw the shear wall. For the drawing the shear wall, we just click the one wall, that one beam, just right click on a screen and say element and the extrude. Whenever you are saying the element and the extrude, same way you can see the extrude type, that is the line or planar element, and that is again in the line or planar element the element type is wall. So if you are saying the wall, so again it's asking whether it is the one way or the two way, sorry, membrane or the plate. So if you say plate, so it's take the in plane and the out of the plane movement. If you say only the membrane, it's only take the in plane movement. So same the wall ID is there. So according to the wall ID is taking care for the design. Then again in the bottom you have to mention about the in which direction you want the shear wall. So generally we want in the Z direction only, so we have to mention the 0 comma 0 comma and the height of the wall. So that is the shear wall description. The once the shear wall is done, we are going move ahead for the loading. So in the loading, the static load. First we define the static load. In the static load, we define the which type of the load we are applying. So that you have to define in the static load cases. Once you in the static load cases, you have to define whether the self-head, in which case we have the various specific cases. According to the cases or from the database, you have to select the case and then you have to apply into the structure. So same way you can see self-head for the dead load, SIDL, that is the superimposed dead load. So in this superimposed dead load, I consider the our maximum we can say the floor finished as well as the wall load. That is the external load are coming into the structure. That is not the self-head structure of the weight. So whatever the external loads are coming, that I consider into the SIDL. If you want, you can take the that floor finish different, that wall load is different. So it's up to you. It is just a type to define the loadings. And then live load, the type is live earthquake X. That's why give the name EQX. The name whatever the you want you can give. It is the just the name, but the type you have to be a specify names, earthquake, wind, or whatever the things are there. Once you define the entire thing, first select the member and go to the element. So generally in the element, you have to say you have to mention the load case, which load case is there, and according to the load case, you have to give the W value. Even in the load type, you can see the uniform load, that is for the UDL. If you want to concentrate force means some point load, so you can apply the point load and these things. So these are the some options are available in our software. So only the things where you can get, so you have to go to the element in the beam load element, so you can see the loading. Now next, once the this thing is done, the next procedure is slab loading. For the slab loading, in this our option in our MIDA chain, we have the two methods to define the slab loading. The one is the plate method. Plate means you have to model the plate, and according to the finite element analysis, it transfer the load on the connecting beams, not on the that any beams, connecting beams. So you have to first mesh the slab and according to the meshing is transfer the load. And the next is the membrane analysis, that is means Okay, 1 minute, sir. Mr. Mahesh Nadkarni, sir, is having some problem with the help of. Are you explaining with the help of the diagram on the screen? No, actually, it's already I opened the one MIDAS file, and it's the same file. According to that MIDAS file, I explain you the entire thing. So these are the 1 minute. I just confirm this thing. Just 1 minute. Okay. After you don't worry about whatever the things we are saying or whatever the things are we are doing, we recorded entire thing, and we share this copy with you, so that in meanwhile if you miss something, or else if you need the something more help, you can get it from the our recording copy also. So we send you the recorded copy. Okay, so now about the loading. So in the assigned floor load, we have the two options, that is the defined floor load type and the assigned floor loads. So what is the difference between the defined floor loads? So you have to first say the defined floor load. In the defined floor load, you have to define the load according to the your uses. That is, we can say it's a particularly template file according to the your loads. So you have to just say typical load, sunk 200, staircase. So that is the things you have to define. Once you define these things, then you have to go to option and say assign floor load, because once you assign, then only the load is assigned, because previously you define only the cases. So now you have to assign. For the assigning, again go to the 3D view and you have to click the four nodes. At the time of the that modeling and these things, if you are facing the some problems, so sometime of you can say in the bottom it's showing that the load is not transfer, or some of the cantilever portions are there. So these are the some errors are coming in the message window. So what is that identification? That is the identification means somewhere your joint is wrong. Which type of the joint means, the generally this is the finite element based analysis. So every joint that your member has to be a brick. If the certain element or certain that frame sections or anything, it is not break, that means it's not transfer the load at particular nodes and these things. So for that reason we have to break the element at every nodes, then you can transfer the your load. Okay, and now next is, once you define the entire loading and this thing, we are moving ahead for the lateral loads. So for the define the lateral load, we have to define first thing, that is the self head. So in the self head, we have to say program to be calculate the self head. So go to the self head, say Z is -1, and say okay in the self-head. Now in the self-head, it's taken care by the program. No need to calculate. Only the thing self-head means what? Whatever the element you draw in MIDAS, it's only take care of that particular element self-head. If you do not draw any element, it's not take the self-head of that particular element. Now next is load to masses. What is that use of load to masses? Load to masses means it is the option which is used for the calculating the seismic weight. So what is that criteria? So according to the 1893, if you want to calculate the seismic weight, so you have to consider the 100% dead load, 100% self-weight, but 25 or 50% only the live load. So that particular things you have to calculate it on the basis of this factor. So you have to only go and you have to say load to masses, and according to the load to masses, you can do the entire things. Okay. Uh, Before, I just wanted to know that you can see the entire screen what I did, and I know that these things, because the Mr. Mahesh Nadkarni is facing the problem for seeing the my window. Whether you all guys are seeing my window, just say, so just type yes or not. Okay. Okay. Mr. Nadkarni sir, can you receive our call? Because from one of my colleague is wanted to talk with you. You just receive the call. He guide you how to see the entire the things and these things. Okay. Now move ahead. So now I just explain you about the lateral loads. About in the lateral loads, if you go to the wind loads, just go to the wind load, just say add, and once you say add, you have to say the first load code. So you have to first define the code. Once you define the code, they are asking the method standard method and the gust factor method. So generally in the most of the software that gust factor method option is not available. So you have to manually define the gust factor values. So once you say the gust factor value, so once you say the gust factor value, so you have to just click and you have to mention the G value. Okay, the G value you have to calculate it manually, but no need to calculate the entire floor loads. So it is taken care by the program. So you only just go to the gust factor method and you can see this. Now the next is you have to define the basic wind speed, terrain category, building class, frictional drag coefficients, and the rest of the all the factors. And only in the bottom that's load direction. If you say x direction 1 means it's taking the 100% value in x direction. If you see the y direction 0, so it is not taken any value in the y direction. Now going, you have to just click on the wind load profile. Now you can see the profile, you can see the storage here. Similarly, you can see the overturning movement. And if you go down in the table, floor wise also you can see the wind force and the story force and the story shear and overturning moment. But how it is calculated? For that reason, you have to go to the make wind load calculation sheet. So once you click on the calculation sheet, you can see the entire calculations. So this is the for the wind load in the both x and the y direction. Only the thing in the y direction you have to keep the x direction is 0 and the y direction is a 1. Now next is seismic loading. In the seismic load I just click here and I just say add. Whenever I say add, I have to select the case name, similarly the seismic load code, and then I go to the seismic zone, which type of the zones are there, soil type is there. Now for the period calculator, again that some formulas are there for the period calculator, just like 0.075 into h raised to 0.75, that is without infill, and for the with infill 0.09 into h divided by under root of d. Now what is that d? D means dimension of the building in the x as well as in the y direction. So that is the things according to the code. But again one formula is there 0.085 into h raised to 0.75, that is for the steel section. So these are the some formula that you have to manually calculate the time period, but in our software no need to calculate the this thing. So you have to just go to the this option period calculator. According to the period calculator you can see the formula is there, so you have to only mention the h if you wanted to change the h. Okay, so according to the your h value is take care by the program, that is the time period in the second. And again the formula is mentioned over there. So which formula you want, you have to just click. According to the formula, you can see the values. Now in the go to the bottom, in which direction you want, 1 or 0 you have to mention. And the similarly accidental eccentricity is there, that is the positive earthquake x, positive earthquake y, negative earthquake x, negative earthquake y. That is also the option is available. If you want, you can use this option. And the one more option, that is the torsional amplification, that is the inherent eccentricity. If you check on this option, inherent eccentricity is taken care by the program of the torsional effect. So generally because of the center of mass and the center of rigidity, if the that plant dimension, that is the 5%, then it is okay. If it is more than this, so some torsional moments are coming, so that is take care by the program. Now the next is seismic load profile. If I click on the seismic load profile, same way what we did in the wind also, you can see the story force, story shear, overturning moment. Same way floor wise also you can see the seismic forces, story shear, story forces, and overturning moment. And for the calculation, click on the make seismic load calculation sheet. Once you click on this in the below, you can see entire calculation. Even it is mentioned about the AH value also, and the same way it is mentioned about the seismic weight also. So it is the same as what we did in the with theoretically. It's the same. So only you have to go and click. So this is the static. And now I move ahead for the dynamic analysis. So I go to the dynamic loads. Okay, once we click on the dynamic load, the next process is the response spectrum function. So what about the response spectrum function? So generally for the response spectrum function, you have to generate the load case. According to the load cases, you have to define the function. Function means what? That is the according to the your z factor or your these values. I soil type, these are the some values. So for that reason, go to the rs function, say add, and say design spectrum. In the design spectrum, you have to mention the seismic zone, soil type, response reduction factor, and the maximum period. So it's depending upon you the which the parameter you are using. According to that, your period versus the spectral rate, that is the acceleration, it is calculated. So you can see the graph and the entire values. If the period we are considering the 6 seconds, so it is up to here. If you want, you can extend up to the 8, 10, whatever the seconds you want. Okay, so I just explain. Okay, so according to this, you have to define. But okay, now I go to the about the RS load cases. In the RS load cases, you have to go to the RS load cases. You have to define the load case name, that is the spectra X. Okay, now in the spectra X, you can see the direction XY, and the excitation angle you have to say 0 for the X direction. 1893 model combination control means which type of the method you are using, SRSS, that is the sum of root of sum of square, or else CQC, quadratic combination. And similarly, we can say ABS, absolute value, and the linear, which is not in the IS method, but these options are available. And according to this, you have to say add. Same way for spec Y, excitation angle will be the 0, and the rest of the values are same. And for the mode shape, you have to go to the analysis. In the analysis, you have to say eigenvalue. In the eigenvalue, you can mention that eigenvector or the reached vector, and in the eigenvector Lancaster's method and the number of frequencies, and you have to say okay. So this is the method that now I just wanted to tell you the one thing. The Mr. Harish Patel is asking the one question, that is the what is the additional seismic load, where to use. See, now I just go to the load and I say static load and I say seismic load. Even in the wind also you can see this type of the value, that is the additional seismic load. What is that? That is means what? Okay, Mr. Mahesh Nadkarni sir, I share you the this video copy so you can see, because I try to call your office but no one is pick up the call. Even you are also not pick up the call. That's why we could not reach to you. So if possible, you can call back on the same number so we can guide you for that how to see the screen and these things. And because all the peoples are see the our screen, but only you are facing the problem. So for that reason. So one more guy, my colleague is wanted to contact you, but you are not pick up the call. So please try to pick up the call so he can guide you. Okay, Mr. Harish Patel, for the your query. Now it's saying about the additional seismic load. See, additional seismic load. What is that? If certain you wanted that particularly floor, the sum according to the calculation, the sum 100 kilonewton force are coming. Okay, but you want the 50 kilonewton, 150 kilonewton. So that it means you have to increase the 50. So according to the calculation, you cannot increase the value of 50. So again, you have to create the sum according to the coefficient these things. So for particularly floor, if you wanted to add some seismic load, so if you want to increase the some seismic load, so you have to go here. You have to select the floor and in the which direction you want that value, X, Y, or Z, that you have to define. So generally, this is a help in the soft story check or the soft story checking. So generally in the soft story checking, that above floor you have to design according to the 2.5 times of the seismic force. So whatever the value you are getting, you have to multiply with the 2.5, and then you have to manually put the value here. So that particular floor is designed for that particular seismic load. So that is the use of additional seismic load. Same this value you can get in the wind also. If you satisfy this option, so you just say, if you satisfy with this option, you have to say okay. Okay. So in the analysis, the load, dynamic load, RS load. In the RS load, we cannot define the additional forces. For the additional forces, you have to manually input the data. So in the dynamic analysis, we cannot increase the dynamic load according to the floor wise. Okay. Again, if you want, we have the one option that is in the load, seismic load, that is the node to load, or else nodal body force, or else nodal mass, floor diaphragm masses. So according to this also you can apply the additional loads. Okay. Now move ahead. Just now our modeling and entire thing is done. For the generation of the floor, sorry, I skipped the one point, that is the for the generation of the floor, go to the structure, say control data, and say building generation. So you can generate the UR floors. Now I just go to the run analysis, perform analysis. For the go to the analysis and say perform analysis. Update the story data. I just update the story data. I just run the model. Once the run analysis is over, we just go for the how to check the parameters, means how to check the results, that I just show you. Uh, I am not showing for the entire building, but some parts I'm showing the how to check the values for the better understanding. But process is the same for the other elements also. So let's see. So within a few seconds, your entire modeling means you can see 17.31 seconds is required to run this particularly entire building. Now next, I go to the results. Okay, the first option is, yeah, first option. Okay, so you can see now the voice is clear. Okay, so now I just tell you in the how to check the results. Now about the result, I just tell you that just go to this option, that is the structure, sorry, results. In the result, say reaction. In the reaction, we have the reaction force and moment. First, we check the reaction force and the moment. Why we check the reaction force and the moment? Because we wanted to know about the scale factor. What is that scale factor? The scale factor is the base shear of the seismic load, that is the static load seismic base shear versus the spectrum analysis base shear. So that we have to match. So for that reason, I just tell you this, go to the reaction, say reaction force and moment. In the reaction force and moment, just go to this option, that is the one more option, that is the just dot dot dot. Before this dot dot dot, I just tell you go to the cell field, click FZ and say apply. Once you say apply, you can see some this type of the arrows are coming. So this arrow means the reaction. If I say value, say apply, now you can see the value. For that, I just change the my view. I just say black. Now you can see in the bottom, its values are coming. Now it's not that proper to see, so I just go and I just select my base points. Now in the base point, I just show you how to see the values. Yeah. Now you can see, or else I just go to the 3D view. Yeah. Now you can see here that 1380, that is the maximum value at particularly this column, that is indicated in the red color. So this is the unique feature in our software. You can see the values, you can see the entire things. This is the display option. You can see the display. Okay, if you change the value to the SIDL, say apply, you can see this is the red. If I change to the earthquake X and I say apply, now you can see here. So whichever the maximum loads are coming, it is highlighted in the red color. No need to go and see in the values. Okay, so that is okay. Now I just do the one more thing, that is the reaction force. Now I want the entire thing in the tabular format. So in the reaction force and moment, in the next to that, the dot 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 option is there. So I just click on this dot dot option, and in this dot dot option I just now clear. Okay, I just explain you one more time. So if you want to see the tabular format, you have to just go the reaction force and the moment next to this dot dot option. Just click on this dot dot option. You have to just select the cases. According to the your case, you can see the value, but if you say none, it's you can see only the summation value. Or if you want that particularly all nodes value, just say don't click on the none option, then you can see here the all nodes options are available. I just say okay. Now you can see the value. Okay, if you want to export to the Excel, just click and say export to the Excel. Or if you want, you can short it by dialog also. Or if you say style dialog, you can change the place means that is the decimal. Or if you want the format also, you can change, that is the engineering, fixed, default, general. So any type of the format you can see here, and just say apply and the OK. Now you can see the value. If I go down, in the down you can see sulfate. It's only coming in the Z direction. That is the 19778.72. That is the value is in kilonewton. SIDL value is there. Live load value is there. Similarly, earthquake values are there. Earthquake X, you can see it is the value is 2081.45, and for the Y the value is 1474.73. And for the spectrum, in the last row you can see in the X value, that is the coming is 870.58, and for the Y it's coming is 1134.21. So this is the some values you can directly get it from the tabular format. Now how we can calculate the scale factor? So for the calculating the scale factor, you have to just divide the value earthquake X divided by spectra X, earthquake Y divided by spectra Y. Okay, so now you can see the earthquake X, the value is 2081.45 divided by your spectra X value, that is the 870.58. So once you divide this value, you can get the one scale factor. That scale factor means you have to see in the load combination. So according to the load combination, you can see. Okay, so for the scale factor, I just open the my calculator and I just show you how it is calculated. So my X value, that is the 2081.45 divided by 870.58. So that is means it's a 2.39. So you have to match your scale factor according to the your base shear of static cases and the spectra cases. Same way in the earthquake Y, my value is 1474 divided by 1134.21. If I click on this value, I can get the value, that is the 1.299 triple nine, or else I can say 1.30 also. For the accuracy, we can say 1.299. So it's up to you which value you want. Now, why it is important? So that is one more thing. Okay, just a 1 minute. The some person are asking about how to check the soft storage, so that I show you at the end of this analysis in the result format. And about the check of the torsional mode, that is also I show you. Just give me the timing, sir. So I am going by step. Whatever the question you wanted to ask at the end of the section, we can see. You just note down the questions. So we in continuationly I can show you the how we can see the results and these things. And for the Mahesh Nadkarni sir, we are the extremely sorry you cannot see the our screen, but I share you the our video link with you. And thanks for giving the your uh, email ID to us. manadkarni@rediffmail.com. Yeah, okay. Thanks for sir. You are providing your mail ID. We directly send you the entire things. Okay, so now the next is go to the load combination. And now I am defining the load combination. Go to the load combination, concrete design. I say auto generation. In the auto generation, it's asking the code. I just say IS456. Now it's asking the scale factor. For the Spectra X, my scale factor is 2.39. I just say add. Similarly, in the Spectra Y, my scale factor is 1.299. and I just say add. Now this is my scale factor is done. Now the next one more thing I just wanted to explain you. It is for the additional of the knowledge, because the first is in the first is you can say that consider the orthogonality effect. What is that orthogonality effect? So generally, if your building is in the irregular shape, so you have to consider the that is if the 100% my earthquake is coming, so in one direction, the other direction maybe my 30% of earthquake is coming. So these are the some combination you have to generate it. So this combination we can directly generate from this option, that is the consider the orthogonality effect. So this is the option is available. See, generally this option is used for the irregular structure, or we can say Y shape of the building, or any other shape. It is not normal rectangular and the this type of the shape. So you cannot exactly know about the principal axis. For that reason, we have to go to the orthogonality effect. So this is the use of orthogonality effect. Once I say OK, you can see entire load combination. Similarly, serviceability, this is for the checking purpose for the deflection and this thing, and the strength, this is for the design purpose. So according to the code, or according to the your static cases, it's directly automatically generate the your load combination. And if you want, you can just click here, and in the right side option, if you want, you can change the scale factor and these things. So it's up to you if you wanted to change. Okay, the one that is Abhinav Hapse, the sir is asking the one question, that is the what is the limit of scale factor, or till what limit we can say the structure is safe. Generally, the limit is maybe the below 4. I can say the scale factor below 4, but it is depending upon the your structure and the your we can say the placing of the column and the shear wall. So if you are again, you have to go to the your drift and these things also, you have to cross check the story drift deflection. According to the deflection and this thing, you can see the whether it is a permissible limit or not, or if it is not limit, so you have to again introduce some shear wall. If you introduce the shear wall, again your base shear and these things are changing. So it's depending upon the your structures also, and the your placing of the column and the shear walls. Okay, and the one more thing, if you wanted to add some, we can say envelope combination. So go to the load combination, and now this time don't go to the concrete design. You have to go to the general and say auto generation. If you see the auto generation, that is the add envelope. In the concrete, add envelope option is there. You have to select the code section, that is the concrete design code, that is the IS 456. The rest of the things are same, and you have to say OK. If you say OK in the add envelope, you can see the entire values and these things. So these are the options are available to generate the envelope diagram, envelope load combinations. Now next, the deform shape. So in the deform shape, I just click on the deform shape. I say deform shape. In the deform shape, I say wind X or else earthquake X, and I say DX animation, and I say apply. Now when I say apply, I just click on this record button. If I click the record button, the automatically the program is recorded, and you can see the values, the deformation. So what is the use of this deformation? So you can know identify how the forces, lateral forces are applied into the building. If the building is moving in the X direction, so means you are applying the force in the X direction. If you see the earthquake X, but the building is moving in the Y direction, that means you are doing something wrong. That is the identification. Even you can see the joints connection between the two these things. You can see the joint connection between the column and the beam. So this is the one option is also available. It's up to you. And now the one more thing, that is the deflection. It is okay. Similarly, if you want, you just say save, and if you save the model, you can save your model into the AVI format. See here, you can see the AVI format. So this AVI format, you can save the file to show them to the client. Same way, you can see the earthquake Y, DY components apply, and if I say record, now you can see the building is moving in the other direction. So from that also you can identify whether the building, how the buildings are move and these things. So these are the some identifications are there. I just close this. close this. Now moving ahead, I just click on any two, three members and I just say activate. Now you can see these two, three members are there. Now, yeah, the Harish Patel sir is asking, can you explain the menu for the animation? Yes, sir. Just go to the deformation and say deform shape. In the deform shape, you have to just click the load case combination, which type of the combination you want or the load case you want, and you have to say whether it is the dx dy or the dz, in which direction, and you have to click on the animate and you have to say apply. Once you say apply, in the bottom you have to click on the record. If you do not click on the record, so that recording is not started, means that your animation is not started. Now for seeing the that bending moment diagram, just go to the forces and say beam diagram. Okay, now click on the forces and say beam diagram. Now in the beam diagram, you can see select the combination. I just select the CL CB1 MY, that is the measure axis for the beam value, and for the all direction I just say apply. Now you can see entire bending moment diagram. So now from this entire bending moment diagram, you can see the entire things are calculated from the center of the sections, but generally I want from the face of the member. So what I have to do, so for that reason you have to unlock the model first, go to the boundary and say panel zone effect. Okay, go to the boundary and say panel zone effect. Once you click on the panel zone effect, you have to say auto calculate panel zone effect or the offset distance. I just say okay, yes, and I again the run the model. So within a few seconds your model is run. So what is the use of the panel zone effect? Means you have to calculate the movement from the face of the member. For that reason we require the panel zone effect. That is the use of panel zone effect. Okay, so now my building and entire structure is analysis is over. Now I go to the next option. That is again I just select this particular element, go to the results, forces, and say beam diagram. I just select the combination my values all and I say apply. Now you can see the entire thing, but you can see the value is not seen because it is in the red, that black red colors. So for that reason I just change my view, that is the background. Now if I go to the come to the this, now you can see my entire values in the white backgrounds also. Now you can, according to this, you can also identify how the beam movements are coming. You can see it is the face of the column and the here also, and the for the beam for the column at the face of the beam, at the soffit of the beam you can say. So this is the option is available, and it is also taken at the time of the design also. At the time of the design it's not take the center to center value, it's take the say the face values. I just say close. Now this thing is done. The next step is detail analysis. So in the detail analysis, see in the beam diagram we have the one option, that is the quick view. If you click on the quick view and just select the any beam, now you can see entire beam generation is there. So according to this beam, anywhere you can click and you can select the combination also, you can select the component also, and according to this component you can see the your bending moment diagram. Otherwise you can type the value here at particular distance, and according to the value also you can see the your results at particular distance also. So this one good option is available. Now for the column you have to cross check the mz value. Now you can see that mz value it's a changing. So for the column you have to check the mz value, and for the beam you have to check the my value. Now the next is I just go to the this option detail element. Just go to the detail element and say detail analysis. Okay. Okay. The Mr. Samir Sawant sir is asking the one question, that is the how to see the envelope forces. Yeah. Just go to the CBC, and in this option you can see the load, the envelope load combination. For the envelope load combination, I just go to the load combination. I say general, add, and that I say concrete. I just say 456 2000. I just say okay. If you see at the below, the strength, for the strength, some envelope combinations are generated. Similarly, for the serviceability also the load combination is generated. Now from that combination, if I see in between, yeah. So envelope strength, that max value, it's a minimum value, and that is for the all. So I just click on the all RCC envelope strength, and I just say my and apply. Now you can see this is the diagram for the envelope. So if you want, I can just show you in the zoom it. Yeah. Now this way also you can see. So this is the diagram for the envelope case. Same way, if I click the quick view, here also you can see in the quick view also. Yeah, now you can see here also my and any type of the values everywhere. So this is the things are available. So according to this, you can see the envelope forces. And now if you want in the detail diagram, just click on the beam element. In the load combination, we have the one option, that is the copy into. So you have to copy the entire data from the other file, and you can paste it here, or else you can say import, and for that reason you have to generate the LCB file. So according to the LCB file, you can generate the your all the data. Okay. Now I come to the next, that is the beam element. So I said beam detail analysis. I just click on the beam detail analysis, and here I just click any one member. If I click any one member, in the backside you can see entire my, this is displacement, this is the shear force diagram, and this is the bending moment diagram. So here you can see the RCC envelope diagram. One more, Mr. Siddhi Pendekar is asking one question, that is our video has got stuck. Can we exit and reconnect through the link provided? Yes, you can reconnect it. It's up to you. And the one more, Mr. Mahesh Nadkarni, I am extremely sorry, sir. If you want, you can leave the session, but I just share this video with you, and thanks for giving the your ID also. So I try to send on today itself, or else the tomorrow or maybe on the Monday you get the entire links. And even the, I think so you also have the my previous these things also, the previous link also. So I try to send you again one more time. And if you have any doubts, if you want the link also, you can directly mail us the mail on the tech support at the rate midasit.com. This is our official technical website. So whatever the doubts you have, you can directly mail us, or whatever, if you want that previous recorded copy or the today recorded copy also, you can mail us if you are not getting the any these things. Yeah, for the seeing the value in the digital format, the if you go to any options, beam diagram and these things, you can see the value. So it's showing the value option. You can see the value, that is the decimal point or the exponential. So if this exponential is on, then it is the, you cannot see the value in the exponential format. and if it is on, then you can see the value in the exponential format. So that format you have to off. And even you can get it from the tools and the preference also, that unit is there. So in this format also, if you want, you can change it. X format, format load, fixed, exponential, the entire things are options are available in the tool preferences. Okay, okay, Harish Patel instead of the expand. Okay, Harish Patel. Okay, so in the tools preference, you can also change the values. Sorry, sir, Mr. Harish Patel, sir, I cannot get you the exactly what you want. So you are saying it's a line menu. The which menu you are saying? I don't, I cannot understand the which menu you want that this exponential result you are getting. The Okay, in the legend also, if you click here, here in the legend also we have this value that is the exponential and the fixed. If you click on the fixed value, you can see the fixed value. If you click on the exponential, see whenever you are clicking on any option, you have to click on this dot dot option, that nearby the dot dot option. So in the nearby dot dot option, you can just click and see the whether it is the exponential or whether it is the fixed. So it's up to you. You can see the value according to the your option. So you have to just click on these options. Now this is the analysis. Now I just go to the results, and one more option I just wanted to tell you about the dynamic analysis. And before going for the dynamic analysis, I wanted to tell you about the result table. So in the result table, go to the story. You can see the story drift. Similarly, you can see the story displacement, story shears in response spectrum, story shear in the time history analysis, story mode shape, story eccentricity, torsional irregularity, even the stiffness irregularity check, that is the stop story check. I think so. One more person, Mr. I think so. Harish Patel is asking the how to check the stop story. So this is the option available in the result table, and in the story, that is the stiffness irregularity check. Okay, the value you can see only in the 5 points. Though if you see, okay, the Mr. But the Chetan Safaria is asking the one question. The moment value in a three division, can I see in the 5 to 7 division? See, we have the one option that is in the display option. In the left side window, you can see display option, that is the exact and the 5 points. So if you click on the 5 points, only it shows the value in the 5 points, not more than the five. Its only value shows in the 5 points. So you have to just click on the 5 points. Now the next is the mode shape. I just go to the before going to the mode shape, I just show you this is the my total building. So just go to the result, and in the mode shape, I just say vibration mode shape. If I click the vibration mode shape, one option is there multi modes. I just click on the multi modes and select the sum 5, 6, 7, 8 modes. I just say OK. Now you can see the four window for the mode 5, mode 6, mode 7 and the mode 8. So these are the mode shape of the building. So now it is the only that animation, or we can say it's only the showing the value of the that shape of the structure. But what about the value? For the value, I just close this. Yeah. Now for the value, you have to go to this option, the vibration mode shape. Next to that, dot 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 option is there. Just click on this dot dot option. You can see the entire value, eigenvalue modes if you want. I just say okay. Now here you can see the radian per second value, that is the omega values frequency, that is under root of stiffness by mass, and the cycle per second, that is also the value is there frequency. So it's a 2 pi n by omega. So according to this, entire the value is calculated, and for the particular mode shape, and the period, that is the t in a second, that is also mentioned in this table. So here you can see that it is the omega value, that is my the frequency, and that is my period. So period, that is, you can say it's a inversely proportion of the frequency. According to that it is calculated. Now if you go down, you can see translation in the y direction. It is showing the 90 percentage in the fourth mode, and similarly for the y it is in the 11th mode. So I have give the 12th mode shape, so up to the 11 I can give, and I am giving the 12, that is fine. So you can see the model participating mass ratio. Similarly, you can see in the my x direction my sum value is 84. Similarly, y is 0. My second is 84. My y value is 0, and my last means third mode shape, my value of summation in the x direction is 84, but that time similarly my summation value in the y direction is the 73. So you can see the first two mode is in the x direction, third mode in the y direction. According to this, you can see the whether it is the coming in the torsional mode shape or not. I think the one person is asking I don't know the name. So they are asking about the torsional mode shape. So torsional mode shape you can see from here whether it is coming in the which situations. And one more thing that more sir is asking the mist. Okay, so mass participation is the below. So this is the mass participation, and this is the sum in the x direction and sum in the y direction. Similarly, you can in the next also you can see the values. So these are the entire values are there, and you can see. Now next, otherwise you can copy the entire things also. You can export to the Excel also. It's up to you. These options are available. You have to just right click on the screen. So this is the only the analysis part. Now moving ahead for the design. So I just click on these two members. So before I started, we have to do some exercise in the design. Just go to the design. First, this option is very important option, that is the general design parameter. Click on this option. That is the first option is definition of the frame. Just click on this, and you can see whether it is your X direction frame is unbrace or the sway, brace or non-sway, unbrace sway or the brace non-sway. These are the options are available. If you do not want, you can click here auto calculate effective length of the factor. So program itself calculate the effective length of the factor. In the general design parameter, LILO reduction option is available. Same way, member assignment, it is the most good option. So you have to always use this option, that is the member assignment. In the member assignment, you have to, what is that meaning of member assignment? So generally what happen, uh, if your column to column is one beam, so at the time of the design it should be calculated the total length is column to column. But because of the finite element base, the every joints you have to break the element. So because of the secondary beam, your column to column beam is divided into the number of parts. But at the time of the design, you want the total beam length for the calculation of the design. So for that reason, you have to use this option member assignment. So go to the general design parameter, click on the member assignment, say automatic, and say all, and say apply. You can see here the program automatically take care of these things. I just show you how it is. Yeah, yeah, you can see here. So entire thing is there automatically. You can see the entire values, and the program itself joined in the one members, and according to the one members you can see the entire values. So see, generally this automatically take care by the program. So how it is calculated, generally you can see the column to column as a one member, and then it goes for the secondary member. So column to column member, if it is break in the 10 parts, then also it's considered the 10 member, and means the total length is the connected with the one member. So you can see here also the first node, that is the index 28, is that 28 and 29 member is clubbed together. So these are the automatically take care by the program. Only you have to go here and say automatic all and these things. Now next is general design. Even we have the, that is the effective length factor option is available. If you want, you can click here. You can see here automatically also it is calculated, or if you wanted to modify, or if you wanted to give, you can give from here also. So this is also the one option is available. So so many options are available. So one of these option is there. Now next is go to the RC design and say design code. If I say design code, I just click on the design code. I just go here and I say 456 2000. If I say click on the 456 2000, you can say apply IS 13920 for a seismic zone 3, 4 or 5. So this option is also available. So if you want, you can click this option, otherwise skip it. So this is option is available. Modulus of subgrade reaction, the factor of safety of soil and the modulus of subgrade reaction. This option is available for the raft design, and the moment redistribution factor for the beam. So generally, as per our manual calculation, the moment redistribution factor for the column to column, the beam is connected. So we release up to the 30%. So only we transfer the 70% of the moment. So this option also you can use here. So if you say zero point 0.7, so it's reduced by the 30%. So this is the one option is available. Now next is RC design, say partial safety factor. So if you want, you can modify the factor. It's up to you. Oh, sorry. RC design design code. I just say select IS456 and I say OK. And then RC design partial safety factor. You can see for the concrete 1.5 and for the steel is 1.15. Whatever the value you want, you have to just click it here, or up to the code also you can set. Means it's up to you. If you want, you can change the value. Again, in the RC design, it's asking the modify concrete material. If you want, you can modify the compressive strength also. But here the rebar selection, it is very important, because in the previously we are not defining about the FE415 or which the strength of the steel we are using. I just say code IS, it's a 415. 415, or if you want you can use, or if you want to use your own value, you have to click here and say none, and you can give the your user defined value also. It's up to you. I just select again ISRC 415 and 415, I just say modify. Now my M40 and M35 grade plus even my main rebar and the sub rebar, that is the first is main rebar, that is the main rebar, and sub rebar, this is for the stirrups. If you want, you can change in the both direction, because as per the IS 456 we cannot take the more than 415 Newton per mm square value for the shear calculation. RC design, I just go to the limiting maximum rebar ratio, so you can set the percentage also. In RC design, design criteria for the rebar, it is the most important. Just go to the design criteria for the rebar. In the design criteria of the rebar, you have to click the rebars. So I just go here, I just select the rebar from the IS. I just select the 12 and the 10. So it's up to you which bar you want. Stirrups, I want 8 mm. Arrangement, I use 230 by these beams. So according to this, I just say it's a two-legged. DT, DT means what? It is the top cover and the bottom cover. I just say 40 mm 0.04, and for the bottom also 40 mm 0.04. Next is column design. Column design, I consider the 16 mm bar. Program itself give the number of bars as well as the AST also. For that reason, we are using this. Bracing for the shear wall also, we are considering the 12 mm bar or else 16 mm bar. And the horizontal beam, I consider the rebar is 8 mm from to 10. Same way the cover external or the outer face or internal face 40 mm, and the 40 mm I am considering. And the one more, that is the one option, so input additional wall data. So if you want, you can use the at the edge also some number of bars also you can use. So some methods are available, you have to define over here. And one more option, that is the spacing of wall rebar, spacing of vertical rebar. So you just click on the spacing, whatever the spacing you want you can consider. I consider here, or whatever the things I don't want, I just delete. I just consider the 100, 112, 125, 150 or 175, not more than the 175. Okay. Now I just select the two members. because it's time consuming and I just wanted to tell you about the results. So I just select the two members. I click here, RC design, concrete core design, and I just say beam design. If I go to the beam design, according to the your load combination, is take care by the program how much the combinations is required. Is take the time according to the your combination. So within the few seconds, it is the your enter the value and these things are generated. Yeah. Now in this value you can see. Yeah. So this is the property and this is the member. What does that mean, the property and the member? The property means according to the property wise it shows the value, and the member means according to the member wise it shows the value. Now I want according to the member wise. So I just say it's a member. Now I just run the two members. That's why it's showing in the this two format. Now entire value is in the kilonewton meter. If you wanted to see the here I can see the I just tell you about what is the exactly thing. First is the BC and HC, that is the breadth and the height of the depth of the beams, and FCK, F5 values, which value we are considering. Position, I mean start point, midpoint, end point. Negative bending moments, load combination. The load combination names are mentioned over there. According to the which combination your beam is designed. AST top, it is in the meter, that's why value is showing in this way. Rebar value, 510 bars are required. So generally I consider in the top floor, that's why the entire everywhere the values are coming same. If I see the bottom, so you can we can get the higher values also. For the study purpose, I just show you the these things. If you see and if you change the sizes also, you can get the difference value at the different places. Similarly, stirrups also you can see two tor at the rate of 300 it is required. Now if I click here, now which beam is here? I just wanted to know. So just click on the connect model view, and if I say click anywhere, now you can see this beam is selected. Now this beam is selected. Same way, if I hide, you can see that it's hide. Similarly, in the backside also you can see. The for the better understanding, I just say just click on the in the bottom that connect model view. If I click here, this property for this beam, if I click here, this property for this beam, so this option is identifying this way. Now I just click here, I just say graphic. In the graphically point of view you can see the value. So these values are shown, that start, mid, end. Similarly, bending moment capacity, the value is mentioned over there. Load combination factor strength, check ratio, required rebar, top, bottom. Similarly, shear capacity also for the which combination and the which values are coming. You can see here. But this is only the summary. I want in the detail format. Just click here and I just say detail. In the detail, once you click on the detail in the below, you can see. Yeah. So the check area for the tensile reinforcement. So maximum is 0.04 into BD. Minimum is 0.85 BD upon FY. So whether it is the greater than AS minimum or less than the AS max. So it is okay. Same way if you go down, you can see the entire shear calculation and entire thing V by VU by BD, whether how the VC is calculated, how the tau C value is calculated. So entire things are mentioned over there. You have to just go and click and see the how it is calculated. If it is the fail, so it is showing whether it is, so now it's showing in the okay, otherwise it show that is not possible. Bending value is calculated according to the face of the member, not at the center, from the face, because we are considering that is the value from the our start point, that is we can say how I can tell you. See, I just tell you this is the total length of the member is 4 meter, but here my start member size is 901 and it is 3.650. So this is the you can see the difference. Hmm. And one more thing, we are using the panel zone effect. Sorry, Mr. Ajit Gokhale sir is asking one question, that is the bending moment value are at center or at a face in a graphics. So it is according to the face of the member, not from the center, because we are using the panel zone effect, that is the rigid zone. So that is my column and the beam junction, that is a rigid area. So from that face I'm considering the moment. So we have to click the one option, that is the panel zone effect. Now same way for the column, I just click here, RC design, go to the concrete code. I say column design. Now here you can see the value. I just say member. I click here. I just say graphic. In the graphically, you can see the values. A 10 number of bars is required for 16 mm. Same way AST is mentioned. If you change the unit, you can see the AST also. Same way applied load, how much the loads are applied, movement, MZ, MX and MY. Similarly, axial forces, moment, and interaction diagram. Now it is the 2D that I show you how you can see the 3D PMM curve also. Okay, and the shear force capacity check is also there. You can see the capacity. Now the one more thing, you can see the draw PM curve. That PM curve you can see in the 3D format. These options are available in the 3D format also. And if you click on the detail, that column, it is designed as per the biaxial movement, and this thing you can see go down, and in the ground you can see check the slenderness ratio, brace unbrace frame, and whether it is calculated non-slender column brace, non-slender column brace according to the minor axis, major axis. It is calculated for the both major axis and the minor axis. According to this it is calculated, and you can see the values are there. Even the check ratio for the reinforcement, compute the design parameter, the balance condition. So entire things are mentioned. Even for the authenticity also it's checked. So these are the some options are available. I just say no. And now one more thing, the Mr. Chetan Safaria is asking the one question. In a beam, can we see the AST in the graphical format? Yes, in the beam also you can see. See here, I just click here and I say RC design, concrete beam design. Yeah, here I just say graphic. In the graphically also you can see the you are still only that it is in the three direction, means start, mid and the end. If you want, you can change it. So you have to just go here and say update the rebar. If you say update the rebar, you can, or you can go here, modify beam rebar, that particularly for these two beam. If you want, you can change the entire things. Just go here, the whatever the property you want, you have to select it. Just go and click the properties. Just go and the bar we want, you have to just go and click here, the number of bars also, as well as these things. Once you click on these options, so you can see the even the stirrups also, you can define any type of the stirrups, which legged and how much the things you want. It's up to you. You have to just go and click on this option, even the cover also, and you can see the entire values in these options also. And I center and J. In this way, you can see the value. You can here, you can see the entire values and center and the start point and the end point. It's in the both way. Now, one more question is asking by the Chetan Safaria. That is the if the column is fail, then how we can correct it. See, if the column is fail, so it is showing in the red color. So you have to first go and see the detailed diagram, means detailed analysis results. So in which form or in which case it is fail. So if it is fail in the which direction, so according to that direction you have to go and change it according to that. So means if whether if you want you can change the grade also. If you want to change the size, you have to generate the one new property, or if you have the previous property, so you have to just click here and say section for the design, and you can change the property and you can modify it value here, and it's take care for the design. Okay, so in this way also you can check. One more question asking by the Harish Patel, that is the will you explain the member assignment function in a detail? Okay, at the end of this session I just explain you about this member assignment function. So it is just I just tell you the at the end of this session how it is implemented or what is the use of these sections, member assignment. Now for the graphical representation, just click right click, design, go to the concrete design result. In the concrete design result, say reinforcement, rebar, it's a beam. I want that main rebar and I just say apply. Now you can see here it's a rebar. Or if I say area, apply, now you can see the area. Now I just change the unit to the mm. Yeah, now here you can see the 344.10. Now it is the values are coming in this way because I'm considering the top beam and not the in betweens, and even the sizes we are considering maybe the higher side. That's why the everywhere the values are coming same. Otherwise the value should not be coming in the same. DT is the top cover. Sorry, Mr. Harish Patel is asking one question. What is the DT and the DB in the rebar selection menu? So DT is the top cover and the DB is the bottom cover. So at the it's a face from the concrete frame. Sorry, the it's a you can say clear cover. It's not a effective cover. It's a clear cover from the US TRS because in the above you can see that rebar and this value already you mentioned. So no need to give the center to center concrete covers. You have to only give the clear covers. Do not give the effective covers. So in this way you can see the values. Now I just tell you about shear wall design. I just open the one shear wall. Now this is the one shear wall. I just click here. Now how you can see the first bending moment diagram and this thing about the shear wall. First go to the result. In the forces you have to say wall diagram. Once you click on the wall diagram, my, no, it's mz, combination you have to select it, value, and I say apply. Now here you can see the, yeah, kilonewton meter value. We are considering the plate element, that's why it's showing in the in plane and the out of the plane in the both direction the value. Otherwise if you consider only the in plane, so it's only showing in the one direction moment diagram values. Now for the design, just click here, go to the design, RC design, concrete core design, I say wall design. If I click on the wall design, here you can see area vertically bar 16 at 175 and the horizontally it's required the 8 or at 160. So end rebar we are not providing the end rebar, that's why it is not used, and the bar layer it's a double means 8 or at 160 two-legged it's required. So it is a mention in this way. If you want you can just go to the graphic, you can see in the graphically also. Okay, is this mentioned over there? Similarly, here also vertical rebar and the entire thing is mentioned. Even the wall dimension, the length into the thickness, that is the 4 meter length, and the zero point 0.3, that is the 300 thickness is mentioned. Similarly, if you go down, axial force and the moment capacity check, MN interaction diagram, shear force capacity check, entire things are there. Similarly, you can just go here, you can see in the detail form also the entire biaxial and these moments it is calculate it's considered for the calculation of the shear wall. Same way eccentricity, that minimum maximum means that is the minimum eccentricity P into we can say the E minimum. So how E minimum is calculated, that is the H by 500 or L by 30, or whether it is the less than or greater than between the or 20 mm. So according to this you have to consider the minimum eccentricity and it is calculated. Yeah. Now, Ajit Gokhale sir is asking one question. Can we have opening in the shear wall? And if yes, how it is created? For the creation, for the sir is asking about the that we can say the modeling part. At the end of this modeling, I just show you because right now I just show you about the shear wall beam. This is the last part, the shear wall. So once the shear wall is done, I just tell you about the your question answer, and then last one I just go for the our we can say document how to generate the dynamic report that I just show you. So before that, I just that sorry sir for the Ajit Gokhale sir, I just tell you how we can generate the wall opening in the wall in the maybe at the later on. So one more question by Ravi Shankar K. It's asking the ductile design of the shear wall. Is that option available or C and T methods design? So generally for the option design code, if you say apply 13920, it's asking the method, which method you are using, and according to this method it is moving for the your calculation. So you can say VU is VG plus A1 sum of MU by L according to these methods. And if you go to the this option, the design criteria for the rebar, in the rebar the input the additional wall data. So we have this option, the specify the end rebar. So this option is available, and the one more option, design criteria some of the rebar distribution. Okay, sorry. The boundary element method of, for the wall ID, this option is not available as per the IS 456-2000, but this option is there. You can see in the RC design, boundary element method for the wall ID by wall ID. So according to the wall ID, you are asking the that question, that is the C and T method that is available in our software, but according to IS 456, this option is not available. Maybe in the this next revision we are implemented this option as per the IS 456 also. Now the Abhinav Hapse sir is asking one question: if the boundary element is required or needed to be provided in the shear wall, how we can model in a MIDAS? So generally, if the boundary is required, so the boundary is required in the design detail at the end of the section. It show the whether the end rebar is required or not. According to that, you have to provide it. Or if you wanted to model it, just go to the RC design and say. Design criteria for rebar, and at the design criteria of the rebar input additional wall data. So here the three methods are there in which you have to define the quantity, means number of the bars, and the spacing also. According to this spacing, it's going for the design and this parameter. So you can see in this way you can analyze and design the entire RCC building structure. And for the again for the beam, so for the design and this thing, I just tell you the one thing, one more thing, that is the footing design. For the footing, right now that we are implemented the IS 456 direct footing design in Design Plus option, but it is now in the beta version, means it is only for the verification. It is means published. Maybe in the next month we launch this software for the market use also. So maybe in the next month you can directly get the design according to the 456 also. So in the design plus, even in the footing, we have the one option, that is the footing design. Just click on the footing design node number. Just click on the node number. Give the concrete grade, rebar, direction, rebar X direction, isolated footing or the pile foundation you want. Select the load combination for the footing. Say OK. Change the column size. If you want, you can change the column size. Reaction force, according to your combination, entire the reactions or force are calculated. And in the option, axial force and the moment only, axial force only, you want that isolated footing or the square footing or the rectangular, it's if you click on this option, so it is give the square footing, or if you want rectangular, just of this option, and you can give the footing inside, means the self-weight should be calculated or not. And if you say okay and then say auto design, once you click on the auto design, just minimize this option. In the back side you can see geometry and the material design conditions, which soil bearing pressure, whether actual pressure, design pressure, shear check, even the one way, two way, both the checks are there, punching shear. And last is the bending moment check. So according to the bending moment, it's give the maximum spacing or the required spacing also. So it's up to you the which the reinforcement you wanted to apply into the footing. So this is for the MIDAS shed. So these are the some feature, that is the beam, column, shear wall, and the footing options are available. Similarly, the raft option is also now the raft and the flat slab option is also available. Now for the flat slab and the raft, again it's required the use time. So maybe in the next few some after the some days, we are planning to again take the some webinar for the raft as well as the slab design. Only first we did for the raft design, then the next way we are did for the flat slab design. And otherwise we can take the same models for the raft design also, but it is maybe the next or maybe the next to next week. But we are planning to do the same thing for the planning. And the one more thing, Mr. Chetan Safaria is Mr. Haresh Patel is asking about the member assignment. So what is that member assignment? Generally, member assignment is used when the column to column beams is connected, but it is divided into the number of part because of the secondary beam or the other beams. Okay, because this program, it is a this program is finite element based, so it's required the nodes or the member to be a break at every junction. So for that reason we have to break the members, and if you break the members, so again it's split into the number of parts. And if you're going further directly for the design, so it's take only the that particularly lengthwise the beam total length. Okay, but we want that beam should be act as a one unit from the column to column. So for the acting the one member that beam to be from the column to column, so you have to use the member assignment option. In the member assignment option, you have to just go and say automatic and say all. And because the program itself first go for the column to column joint, and then it's go for the secondary beam. So these are the options are available. This is the use of member assignment. So any question regarding these options and the design, because the next only the last option is available, that is the design report, that I just show you how to generate the design report. So it's a very quick in manner. So but if you have any doubts in the design and this the results, you can just ask me, then we can, otherwise we can proceed further. Okay, the Ravi Shankar K sir is asking one question. Is there model check option available? See, generally, the most of the option. Okay, so generally in our software, that is a thanks for asking this question. Actually, this section, this option is the most important option available in our software. That is the we can say the check option. So generally in the structure, you have to just go and say check slash duplicate element. So automatically program itself cross check, and it's automatically detected whether it is the duplicate or not. Okay, if it is the member is duplicated at the time of the loading, it's give the error it's that member is duplicated. Okay, and now for the meshing, you are asking about the meshing. The program the it's made according in this way manner, that you have to just go and just click the nodes or periphery of the node. If any in between nodes are coming, program itself automatically consider the nodes and it's passed from that mesh, so that your chances of the error is minimized. Might be I just after the maybe 1 or 2 week I going for the my member assembly, that is the raft design or maybe the flat slab design. So at that time I just show you how the mesh error is eliminated by the our program. So in our software, that mesh error is never come because of it's automatically take care by the program. So it's merged by the program automatically. So we can minimize our errors. Generally, in the other software, we are facing the problem that solution lost error or as well as the load transfer error. But in our software, if you click the any nodes, so if in between the nodes are coming or if in between the your column point is coming, that mesh is passed from that particularly nodes. So for that reason you cannot find this type of the errors. Now Harish Patel sir is asking one question: will it consider all the column member from ground floor to top floor as a one mark? Yes, it is the consider means that if the joints are there, so according to that it is the consider. Or if you want as a the total length from the 0 to terrace level, so you have to use that member assignment option. So that time it's considered 0 to terrace level total length of the member, it is considered whatever the height you are mentioned. But if any joint in between the joints are there, so it's a continuous member, so it's transfer the load from one point to the other points, so it is considered by the program. If you see the member, that is the movement diagram also, then also you can realize how it is the calculated by the program. One more question asking by the Harish Patel, that is if we model the shear wall, either the meshing option will it is better? No sir, because the why we are giving the mesh to the shear wall, because we want that rotational stiffness. Okay, but in our software we have the inbuilt the programming in this way that no need to calculate the or no need to provide the mesh to the shear walls, because the rotational stiffness already we provided in our software. So only you have to mention that plate. So if you consider the plate, it's take the in plane, out of the plane and the rotational matrix. Otherwise, it's not considered. If you say the membrane, so it's only consider in plane and the rotational matrix. So these are the some difference in the other software in our software. Other software, you have to mesh the slab or you have to mesh the wall because you want that perfect stresses and this type of the contour. But in our software, no need to do this way. They automatically take care by the programs. Okay, the Ravi Shankar sir is asking, is there the curve beam and the curve slab modeling available? It's design. Actually, we have the one option that is the curve beam. So just go to this. Okay, now I come to the modeling part because the Ravi Shankar sir is asking about the modeling part. Even that Ajit Gokhale sir is asking about the modeling part. So I come to the modeling part. The go to the nodes and element. So in the nodes and element, you can see the wall opening. First, I explain about the wall opening. In the wall opening, we have this direct option, the wall opening. So we have to just define the dimension x, dx and the dy from which dimension you want exactly you are opening, and the width and height of the opening you have to mention, and you have to just say apply. So for that reason, I just show you. Yeah. So from this, I say 1 meter, say 1 meter, and here it is a point 0.5 by point 0.5, and I just say here and I say apply. Yes. Now here you can see, yeah, this is the opening. In the wall opening, you can generate in this way. So these options are available. Or else, if you want, I can just increase the size. Yeah. Oh, sorry. Yeah, yeah. Now you can see here, this opening is there. So according to this also, you can try, you can give the opening also. Now the next part is Ravi Shankar sir is asking about the circular part. So we have direct option, create a line element on a curve. Just click on this option. We have the option arc by 3 point, arc by center and the 2 points, circle by 3 points. So you have to just define in which method you want. According to that, it is going for the modeling. So these options are available. So whether it is a truss or the beam, it is considered by the program. You can see in this diagram also curve definition. Even it is asking the methods also. Now, one more question is asking by the Harish Patel. It will give the reaction at two nodes only at the bottom of the shear wall. Yeah, it's give only the two nodes or maybe two values at the bottom of the shear wall. Its start point at the end point. It's only give the two reactions. No, sir, it is not the limit of any the opening in the shear wall. It's up to you if you want, and according to that, you have to cross check whether it is a pass or not, how the stresses are coming, and if it is fail, then you have to reduce the opening. Because Mr. Ajit Gokhale sir is asking one more good question, that is there any limit in the opening size? No, sir, it is not the any limit. It's up to you, or it's a maybe a structural point of view. So whether it the member is passed, then it is fine. Otherwise, it's fail. So you cannot go you cannot provide the more the opening space. So you have to reduce that opening space, or else you can use only the two columns, and in between you have to generate the some beams in this way. Any more questions regarding the modeling and the analysis and the design things? Otherwise, I can proceed for the my report generation. Okay, the Mr. Ravi Shankar sir is asking one question. Is there detailing slash AutoCAD drawing? Yes, the detailing option is there. We have the one module that is the D shop. D shop is used for the detailing purpose. So you have to just go to the file, export, and say MIDAS drawing file. So if you say MIDAS drawing file, that particular file, you have to go to the our next option, that is the MIDAS D shop. You have to import into the MIDAS D shop, and you can directly generate the drawing. It's give the total detailing for the beam and the column. For the wall, it's give only the schedule form, and for the slab also you can define the over there. We have the one option that is the MIDAS drawing. Okay, in the MIDAS drawing, it's the same as the AutoCAD. So in the MIDAS drawing, you can type or you can edit anything, and that file you can save as in the DWG format also. Yeah, you can generate, you can create the cantilever slab. Only the thing you have to say the plate element. So I just show you how we can do. I just click here, right click element, I say extrude, and from the line to a planar element, I say I'm not remove that source. Plate element is there, M35, 300 thickness I consider, and I just say in the X direction, I say it's a 1.5 meter. I just say apply. Now here you can see here the cantilever slab is generated, or if you want you can just click here, and you can mesh also. You just click here because mesh is most important. Just click here, auto mesh, say it's a planar element, give the auto meshing, apply. Now you can see the member is black. So in this way you can give the that cantilever slab also. Now next section is asking by the Mr. Harish Patel, that is the what is the wall ID, what is the use of it. So wall ID is the very important before, because if the wall ID you are giving the same wall ID to the two different wall, so at the time of the designing it's not going for the design, even it's average the stresses also. So individually wall, so you have to give the one ID, and for the different wall you have to give the another ID. So if you give the same ID, your all the stresses and all the values will be the merged, and it's give the wrong answer. Now, so for that reason, you have to change, or you have to in a same floor, you cannot give the same wall ID to the two different wall. So you have to change the wall IDs. Now, one more question asking by, okay, so if you wanted to see the wall ID, just go to this option, display option, go to the element and say wall ID. Display option, element and say wall ID. If you say apply, now in this diagram you can say it's a first or the second. In the same way in the diagram you can see. Okay, the one more question is asking by Mr. Vijay Kilari. Even if we delete the diaphragm, then also it should the value of wind x and the wind y how it is. Yeah, see if you delete the diaphragm, so first in the structure, in the control data in the storage, you have to say do not consider. Okay, the diaphragm. If you say do not consider that particular level, it's not considered the diaphragm. See, it's not considered the diaphragm, so it is not taken care in the wind analysis. So do not delete the diaphragm. You have to go here and you have to say do not consider the diaphragm. That particular floor, it's not considered the diaphragm. So you have to use this option from the control data, story data. From that floor diaphragm, you have to say do not consider. So it is not considered for the analysis of that particular floor for the wind analysis. Yeah. So now I think it's a maybe a time maybe it's a more than the maybe it's coming to the 2 hours. So I just show you about the dynamic report generation, and after that whatever the points or whatever maybe we can say the question you have, you can directly mail us on the tech support at the rate midasIT.com. So we give you the as soon as early we solve your problem. So for the generation of the data, you can see this is the my plan. Right click and say dynamic report image. I just say image one, okay. In the 3D, right click, I just say dynamic report image, okay. Same way, front view, I just right click and say dynamic report image, image 2. Otherwise, same way, if I want, I can say the reaction. I just run the model because of I just of these things. Similarly, I can that import the all these parameters also. Means that is the wind and the wind load, lateral loads also. The diagram also we can capture that. I just show you. Just go to the loads, wind load, and in the wind load profile, the near to the close option, image capture option is there. WL proof. I just capture the one image. Similarly, for the results, reaction force and movement, I just click on this. Just click here, none. I say okay. Right click and I say dynamic report table. I just say close. Now for the dynamic report generation, go to the tools, say generator. In the dynamic report generator, I say new document, and it's a, Microsoft Word document. Whatever the things you want, you can type it here. So it's depending upon you, or if you want, you can copy the your entire data from your the standard document also. So I just type whatever the things you want, and from that you have to just go to the report and you have to say the image. Just drag it to the screen. Image 1, image 2, Means it's up to you how you can capture the images. Whatever the images you want, you can just capture it. Same way, the reaction table I just copy here. And one more, that is the WL proof. Okay, so WinLoad, in this way you can capture the entire things. Okay, now somehow the some changes are happen. So if I delete some floors, okay, now these floors are deleted. So again I go to the my report editor, just say auto regeneration. Once you click on the auto regeneration, say select all. Same way if you want to change the table, chart, text, you just say regenerator and say OK. Now here you can see all my figure is changed. So this is the use of the our dynamic report generation. It's very fast. If you use, you can directly automatically you can generate your data, and you can edit the data also, because of some reasons architect changed your plan and the entire design also changed. So again, no need to generate the entire report. Just click on the auto regeneration. Entire the whatever the things you capture automatically updated in the our WordPad sheet. So if you have any doubt in the MIDAS gen regarding the analysis, modeling, analysis and design, you can just mail us on the tech support at the rate midasit.com. I think so. I have clear all your doubts. So if you have doubt, you can directly mail us. And thank you for listening me. And I try to send you the entire links to you. So my team is send you the entire my list that webinar recorded copy to you. Just download from this link and you can see the same thing according to their times and these things schedules. Thank you so much for listening me.